Hi everyone, welcome back to the Saga Tech Gates. In today's video, we are exploring one of the most important conditional construct in Verilog, the case statement. Whether you are building an ALU or are designing a finite state machine, case makes you code clean and readable. So let's get into it. So this is a simple syntax for a case statement. So the case statement is a multi-way decision statement that tests whether an expression matches one of the expression means a case items in the list and branches accordingly. So now here it is a multi-way decision statement. An expression is matches one of the case items in the list. According to that, we'll execute that block. For example, this expression matches with this case item 3, then we'll execute this one. Clear? The expression in the parenthesis evaluated once and compared to the list of alternatives in the order they are written. And matching case item statements are executed. So now here, so the expression in this parenthesis evaluated. After evaluation, then it compared with the case item one by one. The order they are written actually. So the match case item, for example, case item is matches with this expression. We're executing the statement 2. Like, so in case expression comparison, the comparison only succeeds when each bit matches exactly with respect to the values of 0, 1, x and z. So now in case of case comparison, it should match with exactly with all the bits. Okay, 0, 1, x and z. For example, if you want to write multiple statement under these case items, then use a begin and end. This is a simple syntax. So like in other programming language C, so we use this case statement. So this is the most very useful conditional constructs to write a Verilog code in behavioral modeling. Most of the time we'll use a case statement only. So now this is a simple syntax for the case statement. So the default statement is optional and only one default statement is allowed in a case statement. So this default statement is optional, only one statement we can use. So if none of the case items matches the expression, the statements in the default item is executed. For example, this expression is not matched with any case items in the list, then the default statement will execute. The case statement can be nested. We can nested this case statement. We can write one case statement in another case statement also. Right? So now multiple input signal combinations such as 2-tick B00 or 2-tick B10, 2-tick B01 that cause the same block to be executed are put together with a comma symbol. For example, let us consider here. I'll explain with some example. So now this is my case item. In this case item, I can write a 2-tick B00, 2-tick B01 and 2-tick B11. So these multiple combination I can use by separating comma. So I can execute. So see, so 2-tick B00, 1001 that causes the same blocks to be executed. So whenever the expression matches with 00 or 01 or 11, we'll execute this statement 1. That is the meaning of this statement. So if none of the item matches with the expression, and there is no default statement. So we didn't write any default statement and the expression is not matched with any item, then execution will exit that case without performing any action. So without performing any action, so the execution will exit from the case statement. So now see simple example, 4 to 1 multiplexer. So now this is the truth table for corresponding 4 to multiplexer. This is the logic diagram for a multiplexer. So we use this case statement in a behavioral modeling style. So always we'll use in initial and procedural block only. Now for example, if I try to write a Verilog code, especially in behavioral modeling by using a case statement for 4 to 1 multiplexer like this. So here module name. So we are declaring those as the inputs I0, I1, I2, I3 and S1 and S2. So those are the inputs and also we are declaring this out as a outputs. So we declare this out as a reg because we are using this out as LHS in the procedure blocks. So now always at the rate start, so automatically it takes all the sensitivity list, okay, mentioned in this case statement. So begin case. So this is a concatenation operator. So already we discussed these operators. If not, please visit that video. You get an idea on complete operators used in the Verilog. So now concatenate this S1 and S0. So this now S0 is 1 bit. Here this S0 is 1 bit and S1 is a 1 bit. If we concatenate, then we'll get the 2 bits. Now I'm comparing 2 tick B 0 0. So if S1 and S0 is 0 0, then out equal to I0. So S1 and S0 is 0 0, then out equal to I0. Directly by using this case statement, we are writing, okay, like we are writing this truth table. Simply, okay, by using this truth table directly we can write here. So 2 tick B 0 1. If S1 is 0, S0 is 1, then out equal to I1. Same way, if S1 is 0 1 0, then out equal to I2. So S1 S0 1 1, the out equal to I3. Default, if the case this expression is not matched with any items mentioned in this list, then default out value is 0. The simple way to write, okay, implement this 4:1 multiplexer using case statements, right? So now for this, we'll use only a truth table. No need this logic diagram. Clear? Unlike a gate level modeling. So now we have another two statement, casex and casez statements. So in a case expression comparison, the comparison only succeed when each bit matches exactly with respect to the 0, 1, x and z. Clear? So in case of a case expression comparison, each bit exactly match with this 0, 1, x and z. Clear? So or else, for example, if in the expression we have something 0, 1, x, 1, then that item should be 0, 1, x, 1 like that only. Clear? So now two other type of case statements are provided to allow handling of a don't care condition in the case comparisons. So we'll see that case x and case z. So here case x, it treats all the x and z values in case items as well as in the case expression consider as a don't care. So now we treat all x, z values in a case item and a case expression consider as a don't case. For example, I'll give simple example. I have a 2 tick b 1 x. So here I x consider as a don't care. So instead of that, in a comparison, so it may be 1x, 1 0, 1 1, 1 z. For example, assume that this is my expression 2 tick b 1x. This is my case item. So it should match this, okay. So x is a don't care. So we can consider this as a matching statement. So it is also considering a matching statement. This is also considering, okay. For example, 2 tick b 1x, if any case items like this, 1x, 1 0, 1 1, 1 z, it is considered as a matching statement. So we can execute corresponding statement belongs to that case items, right. So now here 3 tick b 1x z. So in this case x, both x and z values are considered as a don't care. So if my case expression is like that, so 1xz, that may be equal to 100 or 101, 110 or 11, anything. Okay, so all are same only. Okay, for example, this is my expression. So these any combination of these four consider as a matching statement. Clear? Matching case item. So kz, it treats all the z values in the case alternatives or like maybe in the case items or expression as a don't case. So now we consider z as a don't care in case item as well as the case expression. So bit position with z can also be represented by question mark in that position. Sometimes we'll use instead of z, we'll use a question mark. Now see this example, 2 tick b1 a question mark. What does it mean here? This is assumed as a z. So now it treats as a don't care. Instead of z, we can use 0 or 1, x or z. Clear? So now both are same. This for example is an expression. So this is a case item. Both are matching. Corresponding statement will execute. So we'll see some example, then we'll get an idea. Clear? So now in this case, 2 tick b x question mark. Now either here only z treats as a don't care, not x in case of case z. Whereas in a case x, we consider both x and z as a don't care. But in case z, only we consider z as a don't care. So now here a question mark, it treats as a z. So we can write x0, x1, xx, xz. Both are same only. Clear? Now see this example. So by seeing this example, you can understand how we are using this case x and case z. So now here just I'll define one model here. Okay. So case z example. So inputs 1 down to 0 data and output range 3 down to 0 outputs. So always at the rate star begin, anyway, it will take automatically all the sensitivity list based on the signal mentioned in this case statement. So I'll use a case z and data. Clear? We'll check. Okay. So here what is the z? Case z ignores the bit position z, whereas in the case x ignores the bit position with x or z values. Now see, we'll discuss here. For example, my input is, so data is x1 here. if data is x1. In case of case z, what is that? Z is considered as a don't care. So now we are searching for x1. Clear? So now x, it should be matches. Okay, only z is a don't care. So now if match x, no, here 0, it is not. Okay, matches here z. So what is the z here? Yes, z is a don't care. That may be in case of z you can write. So this this can be, we can write this z0, we can assume as a 10 or 00 or x0 or z0. All are same only, because in case of case z, z is considered as a don't care. So instead of z you can replace with 1, 0 or x or z. But sure, what is the data here? Data is x1. Actually data is x1. Clear? So now we see in this case z. Anyway, it can matches x, but here second bit is 0, but here second bit is 1. It is also not matching. Now here 1 z. Clear? So what is the data is x. It should be x. It should be x, definitely. Clear? So 1, anyway it is not matching. So at z anyway, z nothing but 0 or 1 like that. This bit is matches, that first bit. 1 and z is matches. Clear? Z may be 0, 1, x or z, but it's a 1. Here is x. Now in this case, what is the xz? What is the x here? So now the data is first sec here bit. This x and this x is matches. This x and this. What is the z here? In case z, z is a don't care. So either maybe x0. So in this case we can write either maybe x0, x1, xx, xz. Because z is a don't care. So what is our data? X1. So here is the x1. It's matches. So that is the reason that out equal to 4 here. I hope you understand this example, right? Now same way, for example, take another example. What is our data is 0x. Clear? So now 0x. See here, this is the expression. This is the data is our 0x. So 0 is matches with a 0. What is a z? Z is a don't care. Either maybe 0, 1, x or z. So it can be written as either 0, 1 or 0, 0 or 0x or 0z. All are same because z is a don't care. So now 0x and 0x, it matches. So that the out equal to 1. Clear? I hope you understand this. The next same way, take another example, x0. x0. My data is here x0. Clear? Now here x not matching because x don't x we are not treating x as a don't care here. Okay, z anyway we are treating z as a don't care. Nothing but here z0 can be written as z0 can be written as 0 0 1 0 x0 and z0. Yes or no? What is that our data here? X0. So matches with x0. Now the output is 2 in this case. Like please analyze for remaining data and verify the output whether you are getting correct or not. Okay. Same way, if we see the case x example. So what is like in case x example? We consider both x and z as a don't care. Both we consider as a don't care. Where here only we consider as a z as a don't care. Clear? Now see, in this example, my data is x1. Assume that my data is x1 here. Clear? My data is x1. So what is that here? 0z. What is the meaning of 0z? So here both x and z as a don't care. So we can write this as a 0z or 01 or 0x or 00. Okay, it cover all possible ways because z is a don't care. Either maybe 1, either maybe x or 0z. So now it matches this. Okay, the x1 is, see here data is x1. So now what is x? X also don't care. Either it can consider the 01 or 11 or x1 or z1. There is a possible combination for this x1. These are the possible combination for 0z. So now here matches 1. Okay, 01 and 01. It matches. Clear? Understood. So now the output out equal to 1 for given x1. Clear? Then we'll analyze another example now. Here what is the data here? Data is 0x. So this data is 0x. Clear? So now 0x means what are the combination, possible combination? X can be treated as a don't care. So 01, 00, 0z and 0x. Clear? So now here see, this is a 0z. Already it matches with that 0z. Then output equal to 1 in this case. Same way, if we see, let us consider for 1z. So now data is 1z. Data is 1z. So Z considers the don't care in case of casex. Okay, both X and Z. So we can write 1 1, 1 0, 1 X and 1 Z. Clear? So now here this 0 Z considers a Z is a considers a don't care. We can write 0 0, 0 1, 0 X and 0 Z. Clear? So this is the case expression. These are the case item or case items. There is no matches. Clear? Now in case of this, take this Z0. Z0 means here, Z0 means we can write 10, X0 and Z0 or 00. Clear? It matches here. See this? So in this case, 10 matches. Understood? Clear? So that output equal to 2 in this case. So this kz ignores the bit position with a Z here. Okay. While casex ignore the bit position with X or Z values. So I hope you understand how do we use this case item. It's very useful, okay, to model any digital system in behavioral modeling style. And this casex and kz also very useful, okay, in simulation purpose. In this video, we covered a case statement. So the case statement in Verilog is a powerful and readable way to implement a decision making logic, especially when working with a multiple condition like in ALU, FSMs or decoders. It helps make the code cleaner and easier to maintain compared to the multiple if-else statements. So always remember to include a default case to handle unexpected or undefined inputs, ensuring safe and predicted hardware behavior. Thank you very much.